This problem is problem number 8 on page 3. This is an interesting problem involving change of energy. Of course, energy is both heat and work. And here we have this insulated cylinder tube here that no heat can come or leave from this. This piston head is insulated. This is all insulated, so no heat can leave the system. And it says that at the beginning of this experiment, you're able to inject 500 joules of heat into the system. Now I want you to imagine what this would be like if I put a little pin right here on that system and didn't allow for the expansion of that piston. And then of course I sealed up the leak here so that no energy can leave or enter the system. If this is perfectly insulated, that 500 joules of heat will remain in there forever and it'll never change. However, it says that during the experiment the piston was allowed to move. And so the piston goes up and does work on the atmosphere. Work is leaving the system, so that's going to be a negative quantity. As the work leaves the system, this little piston head is allowed to move up, and the volume inside here has increased. But notice something left the system. In this case, because this is allowed to move, something left, and it says that 75 joules of work was done onto the atmosphere. That means that the internal energy of this would have had to go down by 75. So it started out with 500 and it went down by 75 joules. So the change in the system was a negative 75 joules. So I see the answer to this I would choose as selection D. The change was negative 75 joules consumed in the work of pushing that piston up.